How can a massive steel ship float while a tiny steel nail sinks? Why do some objects stay on the surface while others go straight to the bottom? The answer lies in an upward force called buoyancy. Whenever an object is placed in a liquid, the liquid pushes upward on the object. This upward force is called the buoyant force. Buoyancy is the reason objects appear lighter in water. Let's see buoyancy in action. The block is first hanging in air. The spring balance reads weight in air equals 10 newtons. As the block is lowered into water, the reading on the spring balance decreases. Now the spring balance reads weight in water equals 7 newtons. Why did the weight decrease? Because water is pushing upward on the block with a buoyant force. The buoyant force is equal to the loss of weight in water. So, substituting the values, 10 minus 7 equals 3. The water pushes upward on the block with a force of 3 newtons. When the block enters the water, it pushes water out of the way. This is called displacement. The amount of water displaced depends on how much of the object is submerged. Most importantly, the volume of displaced liquid equals the volume of the immersed part of the object. Archimedes discovered an important rule. The buoyant force on an object equals the weight of the fluid displaced by the object. So if the displaced water weighs 3 newtons, the buoyant force is also 3 newtons. Whether an object floats or sinks depends on density. Density tells us how much mass is packed into a certain volume. Objects with lower density than water float. Objects with higher density than water sink. A steel nail sinks because steel is denser than water. The nail is compact and displaces only a small amount of water. But a ship is different. Although ships are made of steel, they are hollow and contain a large amount of air inside. This lowers its average density and displaces a huge amount of water, creating a large buoyant force that balances its weight. So, the ship floats. Key points. Liquid exerts upward force on any object immersed in it. Objects appear lighter in water. Buoyant force equals the loss of weight in water and the weight of displaced liquid. Floating and sinking depend on density. Ships float because their overall density is less than water. From tiny nails to giant ships, buoyancy explains how objects behave in fluids. Physics helps us understand the science behind floating and sinking. But here is a question for you. Can an object remain suspended in a liquid without floating or sinking? Yes, it can, if the density of the object is exactly equal to the density of the liquid.